Great. Hi everyone. I'm Andrew Taylor. I'm an emergency physician, so a little bit maybe different background than our other talkers today. But I wanted to talk to you all about kind of the research that we do within the healthcare environment, focused around using data science to improve patient care. So like I mentioned, I work in the emergency department. I'm an emergency physician, and then I also have a background in informatics and data science. My kind of initial interest in utilizing data science kind of in this space was mostly focused on predictive capabilities. We run into a lot of decision-making problems within the emergency department about dispositional decisions, trying to figure out whether somebody is safe to go home, whether somebody's going to have a bad outcome in the hospital and things like that. And it's honestly pretty difficult to figure out which patients kind of utilizing all of their data are going to have those types of outcomes. And it's quite apparent that areas such as machine learning and other areas of data science potentially could be helpful in synthesizing that data and more effectively utilizing that data to make those types of predictions. The other thing I wanted to just kind of harp on a little bit is this idea of medicine kind of being focused around an information science, or kind of changing into an information science. I think this transformation has really happened in the last 4 to 5 years, increasingly both kind of on the large nationwide kind of research networks, and also even within hospitals and kind of learning health environments. People are kind of viewing information that is created through the healthcare process is being potentially helpful, and utilizing that information for a variety of different care needs. That's both for identifying subpopulations through either computational phenotyping type mechanisms, through doing predictive analysis, through kind of cleaning data and ensuring quality components, through other types of methods. And so there's just been a lot of kind of general interest in this space in the last few years. So I have kind of a diverse set of interests in this space. I think all of these are kind of geared towards what can I do to try to change patient care and help patients. But these are kind of the main areas that I have interest in. So predictive analytics, using natural language processing in a lot of various tasks. Phenotyping, we'll talk a little bit about that. Some computer vision applications, and then some unsupervised learning techniques, and trying to kind of better understand representations of patients and how those representations of patients can lead insight for both clinicians, and then also for how those kind of representations may be helpful in predictive tasks outside of kind of that normal unsupervised approach. So just to give you kind of an idea kind of in the predictive modeling space of kind of things that we've done in the past and our kind of areas of interest. So we've focused on urinary tract infections in the past. Be surprised how difficult it is to actually make a diagnosis in that space. There's a lot of noisy data components, and so it's not as easy as you would expect. And we often get it wrong about 30 or 40% of the time. We've been interested in mortality, both from kind of in-hospital mortality aspects. We're now interested in kind of making predictions on opioid patients, or patients that come in for withdrawal, and what their mortality is going to look like within the next year. We've had interest in sepsis, which is kind of like a severe infections, return visits. We recently did some work on COVID-19, and I'll focus on that, and acute kidney injury. So, I think obviously a lot of research has been done on COVID in the last couple of months. We, as kind of emergency physicians, when we were initially looking at this and figuring out, what would be potentially most helpful to providers in the emergency department, kind of utilizing the tools that we have, we felt like making kind of predictions on patients and their decompensation. So, do they get worse within a short period of time, is particularly helpful to us, because we're trying to make decisions about whether that patient needs to go to the ICU or whether they need to go to the floor. So we kind of set out to build a machine learning model to kind of both figure out what features were potentially important in making those predictions, and then also for the predictive model to be put into use. So that was the initial intent. And as kind of you go through, there's always this balance in the clinical space when you're trying to apply machine learning tools about kind of a usability standpoint or interpretability standpoint. We realized that we weren't seeing huge performance differences between a large kind of XGBoost model and a very simplified model that just used respiratory and other kind of variables in the respiratory space, so pulse oximetry and flow rate. So what ended up happening is that we kind of, while we did publish the machine learning model, we ended up focusing on this very simple kind of prediction rule that had just a few points. The nice thing about that is that it's easy for physicians to interpret and to use. And so we were able to get it out online and into some kind of widely used calculators. So MD Calc is one of the ones that physicians often use for making different types of predictions and prognosis. And then also there was, it was kind of uptaken by our main kind of educational group. And so we've had, I think, pretty widespread dissemination of this tool for making predictions about patients in the first 24 hours. Another area kind of that we've been looking at in the opioid space is on disease trajectories, and this kind of goes into several different things. So one is kind of a prediction, that's an initial step in kind of what predictive tools we might be able to build out of it. Two, it's kind of a more exploratory look into what types of things kind of are contributing to final terminal opioid events, and that may be opioid withdrawal or other things. And so we've done work in this space and kind of modeling these trajectories for patients within our electronic health records. So for natural language process applications, I look at kind of natural language processing from the standpoint of an application, more from kind of just basic fundamental development. So we're really looking at how we can use it to further different tasks. And so that may be kind of entity extraction and getting that into data that we can use for both either operational reporting or other predictive tools. It may be actually using it for classification. And the kind of example that I would give is in the predicting these kind of opioid events. A lot of the contextual information about the actual withdrawal event or overdose event is not really captured through structured data in the electronic health record. It's going to be captured better through the notes when they're talking about, you know, what kind of events led up to the withdrawal or overdose. And so utilizing natural language processing and making those types of classifications or predictions can be very helpful. Sentiment analysis is used from like Press-Ganey kind of scores, which are kind of basically patients' kind of perceptions of how their emergency department visits or other visits within the hospital happen, and we can get insight into kind of what structural problems may be wrong with kind of the way we deliver care processes within that. And then we've done some work around knowledge graph construction and using knowledge graph within natural language processing applications. So this was some work that we did for kind of figuring out the similarity between sentences that occur within the kind of healthcare space. And basically we kind of did this combined multimodal approach where we were utilizing both a kind of a BERT-based text encoder and then also applying a graph neural network on top of that, and then combining those features in a fusion type method to better predict kind of the similarity between these sentences. Another area that we focus on is in phenotyping, and this is both in more what I would call like more traditional type phenotyping, which is kind of a rules-based, you know, if a white blood cell count is greater than X, and if the patient has a past medical history of like hypertension or diabetes, then they have, you know, X disease, and as opposed to like a more machine learning based approach where you take tons of different features and you come up with some type of classification rule for kind of putting people into different buckets. In particular, right now, we're focused on opioid phenotyping in the emergency department space. We have a grant from NIH to look at this. There's a lot of kind of overlap in the phenotypes. and presentations for opioid patients in the emergency department. And there's a lot of kind of classification and inaccuracies in current methods for capturing those events. And so our work is kind of focused around how better to improve the identification of those patients and understand kind of the relationships that happen between those patients. In the computer vision space, I'm not primarily a computer vision kind of person. I have interest in it really from just kind of a multimodal kind of fusion approach, and how best it might help with some other particular task. We have done some work in kind of fracture synthesis. So one of the things that we did is we took pictures of fractures that were readily available on the internet, and then we used GANs to kind of generate new fractures that were kind of synthetic radiographs. And the application is that you can then use those kind of synthetic data sets that you create with fracture patterns for educational purposes. And so that you can kind of disseminate those to students to be able to help them in their learning process. Other areas we've done is kind of combining different approaches for looking at pneumonia and other things, both combining both the textual kind of representation of those types of presentations through the provider notes, and then combining that with the imaging data and some other data to kind of see if we can get better representation within that space as well. And I talked a little bit about computational phenotyping. So we've done some unsupervised learning. One of the spaces that we kind of looked at was in looking at chief complaints, emergency department chief complaints. So what the kind of graph on this right represents is kind of the embedded representation of those chief complaints. And then what we did is what's shown here is we overlaid the kind of presence or absence of a lactate, a positive lactate value. And basically a lactate is a way of kind of figuring out whether somebody is sick from sepsis. And so you can see the kind of the areas that you would expect people to be more severely ill have kind of higher lactate areas. So people kind of in the altered mental status realm in the sepsis alert area are kind of in that space and that have flu-like symptoms. And those people with kind of just basic fevers tend to have just normal lactate levels. And so there was some insight that we kind of gained from how chief complaints kind of have representation for lactates and other things and severity of illness kind of inherently within them. And this is just some more kind of demonstration from that space. So these are the actual chief complaints kind of embedded in a two-dimensional space. This is just kind of showing the face validity of the process. And you can clearly see that like genitourinary types of complaints are clearly grouped together. And so, abdominal complaints are clearly grouped together. This says one of the other reasons why we were interested in this was because that right now there's not a clear ontology or standard around chief complaints, and kind of learning this space was a potential data-driven way of kind of informing that process and moving forward. And the reason the kind of larger scale applications for that is that a lot of the kind of quality measurement that happens around emergency care is driven by chief complaints, and there's a shift towards kind of measuring quality on a chief complaint level as well. And that is it. I will stop there and see if you have any questions.